Is a homework assignment due today. Did anybody have any questions on that they want me to go over? Okay. So things that we need to know for tomorrow's test. We need to know how to work with algebraic numbers or polynomials. Add, subtract, multiply, divide. We might have 3x squared plus 9x minus 12 plus 5x squared minus 2x minus 3. And to add these, it's just a matter of lining them up just like we do whole numbers. So we write out the first one, then we line up the digits that have the same place value. So the 5x squared goes under the 3x squared. The negative 2x goes under the positive 9x. The negative 3 ones goes under the negative 12 ones. And we are adding these two numbers. So we'll start at the right and work our way back to the left, just like we do with whole numbers. We don't have to go that direction here. It's just force of habit. So we're going to combine the ones. Negative 12 plus a negative 3 is a negative 15. 9 plus a negative 2, positive 7x. And 3 plus 5, 8x squared. And that's it, right there. The biggest struggle that people have with these is dealing with the negatives. So remember, when you see that negative 12 and negative 3, it's negative 12 plus a negative 3. I think of the number line. Here's 0. Negative 12 goes that way. Negative 3 goes the same direction. Tells you they're negative. The answer is negative, and it's just adding their two values. 12 plus 3 is 15, so it's negative 15. The 9 plus the negative 2. Here's 0. Positive 9 goes this way. Negative 2 goes the opposite direction, but it's shorter. So that's telling us we stay positive. And since the arrows go opposite direction, it's the difference between their values. 9 minus 2 is 7. If you're struggling with those negatives, talk to me. We'll see if we can help you figure it out. Or maybe show you how to do them on the calculator so you can double check yourself with the calculator. Most calculators have a pretty simple to use negative key. Subtraction. We might have 3x squared plus 12x minus 3 minus 8x squared minus 7x plus 1. So again, we'll write out the first number. Some will ask, by the way, well, we've got parentheses there. Doesn't that mean we have to combine what's in the parentheses first? Remember, parentheses have two purposes. One is an enclosing symbol, which is telling us that we have to do something in it first. And the other is just a separator to isolate a number. And that's what it's doing here, is just isolating this as a single number, and this is a single number. So we've got the first number written out. We take the second one and we line it up. X squareds go with the x squareds. The negative 7x goes with the positive 12x. And the positive 1 goes with the negative 3. This time, however, we are subtracting down each column. Negative 3 minus 1 will become negative 3 plus a negative 1, which is negative 4. 12 minus a negative 7 becomes 12 plus 7. Remember, we add the opposite. 12 plus 7 is 19, and the x is still there. 3 minus 8. Perfect. 3 minus 8, 3 plus a negative 8, positive 3, negative 8. We end up at negative 5, and that is x squared. Might be asked to multiply a more fairly simple one like this. I'm I'm going to try that one in your notes quick, and we'll go over it in a minute. Let's take a look, see how you're doing here. So we look in the parentheses, there's nothing that can be done inside because it's x to the fifth and x to the second. They're not the same name. So we cannot combine anything in the parentheses. So the next step is to see if we can do anything to the parentheses. And that's times the 3x to the third. So 3x to the third times the 5x to the fifth. We multiply the counts. 3 times 5 is 15. And then we multiply the names. 3x to, or x to the third and x to the fifth make, careful, x to the eighth. When we are multiplying exponents with the same base, x would be the base here. We add the powers. 3x to the third times negative 2x squared will be, careful, negative 6, x to the fifth. 3 times negative 2 is negative 6. X to the third times x to the second is x to the fifth. We might run into something like that. Once again, I'm going to give you a minute to try that one, and then we'll talk about it. So where do we start? Perfect. 7x to the 7th times 2x to the 5th, which is? Perfect. 7 times 2 is 14. X to the 7th times x to the 5th. Again, when we multiply exponents with the same base, and these both have a base of x, we add the power. So 7 plus 5 is 12. So 7x to the 7th times negative 3x squared. Perfect. 7 times negative 3 is negative 21. X to the 7th plus x squared is x to the 9th. Next, what do we do? Careful. Okay. Gotta be very careful. It's actually negative 4x to the 6th times the 3x to the 6th. Negative 4 times 3 is negative 12. You got it. X to the 6th times x to the 6th is x to the 12th. Negative 4x to the 6th times negative 7x to the 3rd. Perfect. Positive 28x to the 9th. And now there are things we can combine here. 14x to the 12th and negative 12x to the 12th. They both have the exact same name. Same variable, same power. That's 2x to the 12th. Good. When we add them, we keep the same name, so it stays x to the 12th. Negative 21x to the 9th, positive 28x to the 9th, positive 7x to the 9th. Good. Keep the same name again. We might have now we'll make this easier. We go 3x minus 7 times 4x squared minus 5x plus 2. To do something like this, it's just long multiplication. I'm going to write out the longer of the two first, 4x squared minus 5x plus 2. I'll put the shorter one on bottom, the 3x minus 7. And now we are just multiplying. We start with the last digit in the bottom number, which is the negative 7. Negative 7 times 2 is negative 14. Negative 7 times negative 5. Positive 35, and the x is there. Negative 7 times 4x squared. Perfect. Negative 28x squared. We move on to the 3x. We leave a blank here or put in a 0. 3x times 2 is 6x, it's positive, so I'm going to put a plus in front of it. That lines up with the 35x. 3x times negative 5x. Negative 15x squared. X times x is x squared. And 3x times 4x squared. 12x to the third. Very good. And now we still have to line up and add the columns. So negative 14 and 0 is just negative 14. 35x and 6x is 41x. Negative 28x squared, negative 15x squared is negative 43x squared. And we have the 12x to the third. This one's going to seem simple, but a lot of people struggle with this. 0.4x to the fifth. How many decimal places should this answer have in it? Yeah, there's one decimal place here. We're taking it to the fifth power. There's going to be 5 decimal places here. If it was just 4 to the power of 5, it'd be 1,024. So 1,024 is still going to be here, but it has to be at the end of those decimal places. So it's actually 0.01024. You can punch these in the calculator. The calculator is going to do them for you. This one, it'll give you the answer like that. But let's say you had something like 0.03 to the power of 4. Should only be 8 decimal places, but your calculator is going to give you the answer like that, 8.1 e negative 7. What does that mean? What that means is 8.1 times 10 to the negative 7th power. So that 10 to the negative 7th power means that you have to move this decimal point over 7 spots to the left, filling in zeros. So that's 3, 4, 5, 6, 7. So that is 0.0000081. So be careful with those. Your calculator can kick them into scientific notation. Make sure you remember how to convert. And we can come back to this one later if we have to. A fraction into a decimal, or a decimal into a fraction. Make sure you know how to convert a percent into a fraction, or a fraction into a percent into a decimal, or a decimal into a percent. Along with that, make sure you remember how to calculate percents. Something like this. Blank is 70% of 30. We start out with the percent. That 70% is 70 over 100. Blank is 70%, implies that missing number goes with the 70. Of 30, you can read that as out of 30, implies that the 30 goes on bottom. And we cross multiply and divide. 70 times 30 is 2100. Divided by 100 is 21. So 21 is 70% of 30. And of course, we're going to encounter word problems with these percents. Again, I'll come back and do more examples of those at the end if we have time. I want to make sure I get through some of these other ones first. We need to be able to solve equations with fractions or decimals in them. For example, Something like this. 6.5x minus 9.63 equals 12.47. This is going to be exactly the same as solving an equation like 3x minus 5 equals 22. It's just this is simpler to look at because we don't have the decimals in there. The decimals tend to confuse us. Over here, what would we do first to solve this? Yeah, we'd add the 5 here. So yeah, the equivalent is over here. We're going to add the 9.63, like you said. So that would be gone. We're left with 6.5x here. Over here, this is going to be 22.1. What would be next then? Divide by 6.5 to get x by itself. X equals 3.4. Or you might see equations like this. To solve this, what's the first thing you got to do? Yep, we got to get rid of this denominator. We're going to multiply by 6. Cancels that out. Multiply by 6 over here to get 18. On the left, that 6 is gone. All we have left is 5x minus 2. And from here, it's relatively simple to solve. What's our first step going to be? Add 2. 5x equals 20, and then divide by 5. X equals 4. And we might have some more difficult ones, like make sure you leave some room on your paper for this one. Like that, just a little bit more difficult. Remember, when we have these, we can work on each side of the equal sign first, each side of the equation. We can simplify everything we can. So there's our equal sign. Let's stick to the left side over here first. First thing we have is the parentheses. We're going to multiply through that parentheses by the negative 7. So that 5x doesn't change. Negative 7 times 2x. Negative 14x. Negative 7 times negative 3 is a positive 21. We still have the positive 15 over there as well. Well, from there, what can we still do? 5x and negative 14x, or 5x minus 14x makes negative 9x. And 21 plus 15 is 36. Good. On the other side over here, what would we do first? Here, we would distribute the 4. 4 times 5x is 20x. And then 4 times negative 8 is a negative 32. We still have the negative 9x and the negative 12. We can combine what? 20x and the negative 9x makes 11x. The negative 32 and negative 12 makes negative 44. Now we have everything combined that we can combine. We still see that there's a variable on each side, so what does that mean? Get rid of the smaller one, which will be negative 9x. We get rid of it by adding 9x. So that's gone. These are just 36 here. When we add or subtract, remember we only add or subtract to one piece on each side. So on the right side, we will add the 9x to the 11x because it has the same name. 11x and 9x make 20x, and then we still have the negative 44. Now we are ready to actually start solving. What can we do first? Add 44. So 36 and 44 make 80 equals 20x, and then divide by 20. 4 equals x, so x equals 4. Which wasn't so bad. I might really try to screw you up and use something like this. Throw a mixture of fractions and decimals in there. Now looking at this one, these are all actually pretty simple fractions. 6 3/4 is 6.75. 2 1/2 is 2.5. Or relatively simple decimals. 7.875 is 7 7/8. So I could convert it either way. I could either convert my fractions to decimals, or I can convert my decimal to a fraction. Or I can calculate with them as fractions and decimals mixed, which is kind of a pain. So it'd be better to do the conversion. Do you guys have a preference? Do you want to turn everything into fractions or everything into decimals? Do decimals, okay? So 6 3/4 is 6.75x minus 7.875 equals 2 1/2 is 2.5. And then good, we add 7.875. So that becomes 10.375 here equals 6.75x. And then we divide by 6.75. So we get x equals 10.375 divided by 6.75 is 1.5370, blah, 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 blah. Right? Otherwise known as, what is that, 1 in 29/54? Any questions? Okay. So that's probably about as mean as I would get to you in an equation on the test.
Can we do more practice the long division one?
The long division one?
Yeah. Like when we did like the long division part.
What, like with the equations or?
Yeah. Like, I don't know, like give one more example just to like practice it. That's when I did it.
Which one are you looking at? Like
the one where we did the 3x minus 7 times the 4x squared minus 5x plus 2.
Oh, gotcha. Long multiplication one, you mean?
There we go, not division.
I was going to say, I didn't make you do division with polynomials.
No,
Hey.
I didn't mean to say division.
You had the little
I was
hamster.
doing multiplication in my head, but I was.
That's okay. You just had the little hamster stumbling on me there for a minute. Okay, I'm going to have you guys try this one. Try that one in your notes, and we'll talk about it in a minute. Okay, so here I set it up again the same way. 5x squared plus 3x minus 11. I put the longer one, the number with the most digits on top. Then the number with the least digits on bottom, 7x minus 2. And we are multiplying here. So when we start, just like with whole numbers, the last digit of the bottom number is the negative 2. So we do negative 2 times negative 11 is positive 22. Negative 2 times 3x, negative 6x. And negative 2 times 5x squared, negative 10x squared. And now when we move over to the 7x, we put in a 0 down here, or we're going to leave a blank, one of the two. 7x times negative 11, negative 77x. 7x times 3x. Positive 21x squared. And 7x times 5x squared. 35x to the third or 35x cubed. You're correct. Good. So now we go back and we got to add up the common things. 22 and 0 make just positive 22. Negative 6x and negative 77x. Negative 83x. Negative 10x squared and a positive 21x squared.
11x.
Yep, 11x squared or positive 11x squared. And just the 35x to the third. You better on that one?
I just kind of wanted to do it by myself like that. I guess.
Sure. And you could still do distributing if you wanted to on that. I mean,
Just take longer.
yeah, I mean, to me, it's just easier to set it up this way. I mean, you could still just do, okay, 7x times 5x is 35x to the third. Yeah, that's 21x squared, negative 77x. And what I do when I do it that way, by the way, when you're taught to do it, this is just a variation on the FOIL method. What we're taught to do is just keep going. Okay, now negative 2 times 5x is negative 10x squared. I don't do that. Yeah. Exactly. When I get this next digit, negative 2 times 5x squared is negative 10x squared. I put it under the other x squared. And negative 2 times 3x is a negative 6x squared. Or negative 6x, I should say, not squared. And negative 2 times negative 11 is a positive 22. So now it's already lined up, so I can just add the columns again. Okay. Word problems. We did a lot of work with word problems in this unit, setting up equations for them. One of the things we did kind of a cookie cutter set of problems with perimeters. For example, if the length of a rectangle is 5 more than the width. And the perimeter is 90. Find the length and width. So I would draw out my rectangle. Here's my length, here's my width. I know the perimeter, 2 times the length plus 2 times the width. And I also know that my perimeter is 90, so I can put 90 in where the P is. At this point, however, I still have 2 variables in here. I have L and W. I need to get rid of one of them. To get rid of one of them, I need to express it in terms of the other one. So I need a relationship between them. And that's right here. The length is 5 more than the width. So the length is equal to the width plus 5. So now I can take that and I can replace L in this equation with that expression, W plus 5. So 90 equals 2L is going to become 90 equals 2 times the W plus 5 goes in where the L was. I had to put it in parentheses because 2 multiplies the whole thing. And it's still plus 2W there. So now then, the 90 doesn't change. I have 2 times W is 2W. 2 times 5 is 10. And I still have the plus 2W sitting there. I'm going to combine 2W and 2W. Makes 4W plus 10. Now I can solve. What am I going to do first?
-10.
Subtract 10. 80 equals 4W. And then
Divide by 4.
divide by 4. 20 equals W. So 20 equals W. Am I done with the problem?
No.
Now I'm asked to find L and W. So W is 20. I still need to find L. So L is equal to W plus 5. So W is 20. That's 20 plus 5. L is 25. Any questions? About 30, I think, on this one. Usually it's between 25 and 40. This one I think is somewhere right in the middle. Let's see. Let's do, so we have a garage. Pat wants to landscape around a garage. The garage is 24 feet by 40 feet. After landscaping, oops, let's put it this way. Pat will landscape the same distance away from each side of the garage. The perimeter of the landscaping is twice the garage perimeter. Find the length and width of the landscaping. That one got to be way more to write out than I thought it was going to be when I started. So we're starting out with our garage. It's 24 by 40. This is 24 feet by 40 feet. And Pat is going out the same distance on each side of the garage to put up this landscaping. Yes, I know there's an obvious question here of, well, if they landscape around the garage, how are they going to get a car into it? We're not going to worry about that right now. So I'm going to call this distance here X. That's how far Pat goes out from each side of the garage. Now it says the perimeter of the landscaping is twice the perimeter of the garage. So first thing I'm going to do is I'm going to find the garage perimeter. Well, the garage perimeter is 2 times the length, which is 40, so 2 times 40, plus 2 times the width, which is 24. 2 times 40 is 80, 2 times 24 is 48. So that perimeter is 128 feet. What that's telling us is the landscape perimeter has to be 128 times 2, or 256 feet. We also know that the landscape perimeter is 2 times the length plus 2 times the width. So we're going to replace P here, the perimeter, with 256. 2 times, what are we going to put in there for the length? Well, the length, this length right here, this piece of it is 40 feet. What's this piece here? That's X, right? What's this piece here? That's X. So that whole length now is 40 plus 2X. Plus 2 times the width. Here's my width, my whole width. What's this piece right here? From here to here. That's the 24, right? That's just this dimension. The other thing here to here is X, right?
I'm not gonna lie, I wasn't where you were pointing at.
Okay.
I was just sitting here.
Yep. Yeah, this one here, of course, has to be this dimension. That's the 24. This one has to be the X. And that one had to be X up there. So that's 24 plus 2X. So 2 times the width is now going to be 24 plus 2X. And now we're going to solve for X. So 2 times 40 is 80. 2 times 2X is 4X. 2 times 24 is 48. 2 times 2X is 4X. Then what? Combine like factors. Good. Like terms. We've got the 80 and 48, which is 128. 4X and 4X are makes 8X. Then what? Subtract 128 from both sides. So 256 minus 128 is 128 equals 8X. And then divide by 8. So 16 equals X. So that's telling us is Pat is going 16 feet out on each side of the garage. That's not what we were asked for, though. We were asked to find the length and width of the landscaping. Well, this length here is the 40 feet plus 2X, and X was 16. So this is 40 plus 2 times 16. 2 times 16 is 32. So that's 40 plus 32, or 72 feet, is the new length. The width over here is 24 plus 2X. But X is 16, so it's 24 plus 2 times 16. So it's 24 plus 2 times 16 is 32, which is 56 feet. So the landscaping is 72 feet by 56 feet. That one's kind of a long problem. I will ask one similar to that. It might not be about landscaping. It might be about, could be a deck around a house, deck around a pool, anything like that. Just one problem like that, yes. It depends. I mean, you'd have to try really hard to upset me between now and tomorrow morning. That one's a mouthful. Okay, that's about all the time we have. Do you guys have any specific questions you want me to answer quick before we hang her up for the day? Okay, that's it then.